Lab 2, Lines of Charge. In this lab, we are going to approximate the amount of charge on a floating piece of tape. And this will allow us to become familiar with the idea of charge and design experiments with everyday household objects like tape. Some fundamental physics principles discussed are like charges repel and opposite charges attract. And we're going to look at how to calculate electric field. And force due to electric field is basically charge times electric field. And lastly, force due to gravity will be used later. Lab 1 and Lab 2 has the same procedure, while Lab 1 has point charge model versus Lab 2 has line charge model. For the line charge model, we are basically breaking the tape into many point charges and summing up the charge. To calculate the total E field and total force, we are going to find the electric field and electric force on each charge and sum it up to find the net force in the electric field. Based on the observation, we know that U tape is positively charged because it attracts to negatively charged plastic pen. It was measured to be that tape length is 0.2 meters and mass is 2 times 10 to the negative 4 kilograms. And the upper tape started to move upward when the distance between the two tapes was 0.03 meters. The magnitude of electric force and gravitational force was equal to each other, and this was 1.96 times 10 to the negative 3 newtons, and this is due to Newton's third law. This is additional Lab 1 data. We should note that charge on one tape calculated using the point charge model as shown on the right was approximately 1.4 times 10 to the negative 8 coulombs. And we're going to compare this result with Lab 2 results later on. This is my glow script code. In order to estimate the net charge on one tape, I had to use trial and error to make sure that FE matched FG. And to calculate the electric field, I got the E field function from Lab 0. I've modified the number of point charges from 10 to 20 in order to make sure that the model was more accurate to estimate the net charge on one tape. I had to fix the error scale in order to see both the arrows and the actual point charges for the tape. And to calculate the E field at the location of the top tape, I used the E field function and basically summed it up to find the total E field. And the force of each point charge was calculated using charge times electric field. Lastly, I've set the axes for each arrow representing the electric force and gravitational force so that you will be able to see two arrows pointing opposite to each other with the same magnitude. The computational model shows on the right, and the green arrows are representing electric field, and white arrow represents electric force, and yellow is gravitational force. And you can clearly see that the white arrow and the yellow arrow are in the same magnitude but in opposite direction. I had to assume that air resistance on tape A was negligible and that the charge was evenly distributed across the tape with 20 point charges, and both tape has the same amount of charge. The charge from Lab 1 was 1.4 times 10 to the negative 8 coulombs, which is less than charge from Lab 2, which is 2.8 times 10 to the negative 8 coulombs. And this is because point charge model assumed that the charge was centered in a single point on the center, while the line charge model assumed the charge was evenly distributed along the tape. Therefore, we can say the line charge model shows a more accurate charge value because it models the charge distribution closer to the real-life phenomena. To conclude, we can say there is an excess positive charge on 0.2 meters of tape, which is around 2.8 times 10 to the negative 8, within the range that we expected, and the line charge model value is more likely to be closer to the real value. Thank you.